Welcome to Control Charts video. In this video, we will explain the types of construction of different types of control charts. After going through this video, you must be able to construct different types of control charts. Control charts are complex statistical tools used to measure movement of data over time. They are used to constantly monitor the process by graphical means. If the analysis of control chart indicates that a process is under control, it means the process is stable and no corrections are required. Also, the data obtained from control chart analysis can be used to predict future performances of all processes. Next, let us go through the elements of the control chart. A control chart is a time series graph. This is plotted on the x-axis or horizontal axis and key quality characteristics on the y-axis or vertical axis. Points represent statistics such as mean, proportion or range of quality characteristic taken from a process. The mean of these statistics is calculated using all the samples, like the mean of the ranges or mean of the proportions. A central line x is drawn at the value of the mean of the plotted data. This line detects the variability. Upper and lower control limits or UCL and LCL are calculated from these data and placed equidistant from the central line. Control limits are used to find special causes and capability of the process. If special causes are absent, then the mean, upper and lower limits can be used to find the future capability of the process. Next, let's look at types of control charts. Control charts for variables are used where output can be quantitatively measured. For instance, diameter or depth, thickness of a pipe, etc. Control chart for attributes helps in achieving an acceptable level of quality where the output cannot be quantitatively measured. In this chart, the output can be segregated as good and bad or acceptable and non-acceptable. Next, let's look at benefits of using control chart for variables. There are various benefits of using control chart for variables, some of which are as follows. It warns in advance if any rectification is required to reduce scrap and percentage rejection. It ensures product acceptable quality level. It helps to determine if the process is under control or out of control. It reduces effort on inspection work. It differentiates chance and assignable causes of variations, leading to substantial quality improvement. It determines process variability and detects unusual variations. Next, let's look at use of control chart for variables. These charts are used for measurable quality characteristics of all products, which are divided into groups. These groups are considered as samples having fixed number of components selected randomly for testing. Then, the mean and standard deviation of quality characteristic for each sample are calculated. Next, let's look at 4 most commonly used control charts for attributes. There are 4 most commonly used control charts for attributes, which are as follows. Control charts for fraction defectives or P charts. Control charts for number of defectives or NP charts. Control charts for number of defects per unit or C chart. Control charts for number of defects per inspection unit or U chart. Let us now understand how to construct these charts in details. Under the control charts for variables, X bar and R chart are constructed. These charts are used to monitor process behavior and results over a period of time. Chart is a control chart for means of a group of sample, whereas R chart is a control chart. X bar chart is a control chart for means of a group of sample, whereas R chart is a control chart for ranges of group of samples. Both the charts are plotted in one graph to better understand process variation and identify the causes of problems. Quality experts first analyze the range portion of chart to confirm if process is under control. Then, studies the mean section for the presence of any special cause. Let us now understand how to construct these charts. The following steps are taken to draw X bar and R chart. Step 1. The number of samples of item in processes is taken over a period of time. Each sample consists of n number of units and the quality measurements are depicted as X1, X2, X3 and Xn. Step 2. For each sample, X and R are calculated, where X is the mean of each sample and R is equal to highest reading minus lowest readings. Total average of the sample means is calculated as follows. X is equal to X1 plus X2 plus X3 until Xm divided by M, where M is equal to number of successive sample. X1 plus X2 plus X3 until Xm is equal to means of various samples. X is equal to total average of the sample means. Next, control limits of the X and R charts are calculated as follows. X chart. Read the formula from the slide, where X is equal to total average of the sample mean. R is equal to range of the subgroup. A2 is a factor based on subgroup size. R chart, where R is equal to range of the subgroup. D4 and D3 is equal to appropriate constants based on the subgroup size. Based on the above values calculated, X chart and R chart are plotted. A typical X chart and R chart are shown in figure. Next, let's look at construction of control charts for attributes. If N is the total number of items in a sample and D is the number of defectives in a sample, then P bar average fraction defective is equal to D divided by N. Control limits are then calculated as follows, where P bar mean fraction defective. Pi is equal to number of non-conforming items. Ni is equal to size of the sample. An NP chart is similar to a P chart, with the only difference being this chart is used when the sample size is same as the number of defective items can be counted. Under this chart, control limits are then calculated as follows, where is equal to average number of defective items is equal to mean fraction defective is equal to number of non-conforming items is equal to size of the sample. This chart depicts the number of defects produced in a manufacturing process when the opportunity compared to the actual number of defects is large. Control limits are then calculated as follows, where is equal to average number of defects is equal to number of non-conformities found. N is equal to size of the sample. This chart depicts the number of defects produced in a manufacturing process when there can be more than one defect per unit and the sample size is varied. Control limits are then calculated as follows, where is equal to average number of defects is equal to number of non-conformities found in sample I is equal to number of defects per inspection unit in sample I is equal to average number of defects per inspection unit is equal to size of the sample. The summary of the tutorial on control charts has been put on the screen. I will pause for a few seconds to allow you to read it.